Okay, this should be okay. Sorry about that, guys. It always ends up being that I do check every night to make sure that the audio and video are synced up. Every night before I go to bed. Sometimes I don't check it in the morning because, I'm running late, whatever. It's 5 in the morning. It doesn't seem like if it was working last night that it would break over the night. Yet every single night it seems to break. So I hope that the audio and video are synced up right now. I was just talking about what happened last week in terms of having very few videos. Again, it was basically a situation where if I don't have a sleep schedule set every morning to wake up at the appropriate time, I just don't wake up at the appropriate time. And so you noticed Monday I got up on time. Tuesday, of course, I slept in, which I was trying not to do. I was trying to still get up at 5 and get work done at 5, but I don't know. I just couldn't. I don't know why. So Wednesday, I was late to stream because I slept in and I couldn't keep a consistent sleep schedule. I don't know, it was just a mess, And then Friday, I slept in until like 6:30, which was a day I was supposed to be streaming, and I never sleep until 6:30. It was pretty bad. So yeah, basically the point is I should probably just keep streaming every day at 5, and that's where we're gonna be. So again, today is gonna be basically tying up a few loose ends here and there. It's gonna be a little bit slow. I'm gonna go ahead and let you guys know that right now. The idea is that I need to finish up 1 or 2 visualizations for the color quantization video, and then I need to go ahead and finish up that triangle of triangle things with the OpenGL stuff. And what I want to be doing most of today, what I want to be spending most of my time on today, or rather this entire week, is basically getting everything ready for the Galaxy simulation video, which will be upcoming on my next YouTube channel video. Yep. And the reason is kind of simple. We've basically finished up the color quantization with the Octree stuff. Works quite well. Yeah, it's not as fast as it could be. It's a little bit slow, but at the same time, that's perfectly okay. This is just kind of an example code. It's not meant for any specific purposes. Let me see. The other thing I want to point out is I'm going to be treating Twitch instead of as individual episodes like I was doing before. Last week, I'm going to be treating it as basically a way for me to get work done while people help me out. That's what I'm going to be doing there. So I realize that might be a little bit boring for some of you guys, and I'm going to try to have more high quality streams every now and again. It's just a matter of getting everything else working, and with YouTube and Twitch and obviously my PhD studies and everything, it's kind of difficult. Anyway, guys, Gustrun, I love Twitch, Happy Little Rat. Thanks for coming in, guys. One last thing I want to point out before getting started today, because again, we're just tying up a few loose ends here and there. There was this postdoc rant. Oh, I guess there's 2 other things on the physics subreddit. I guess if I refresh it, there might be more people. Yeah, it was all about basically academia in the U.S. right now, and how I guess hard it is to make ends meet. And the thing that really got me is this guy is a postdoc working in plasma physics based in the U.S. That is exactly what I used to do before coming here, and is something that I would probably continue to do if I went back to the U.S. And he talks about funding, he talks about the replication crisis, he talks about everything else there is in trouble with the U.S. right now in terms of getting science funding out there. And I just thought, okay, go ahead and give you guys a link to it in case you guys don't have it. I don't know, I thought it was kind of hit me home, I was like, geez, it's kind of a pain that even, a hard science like physics is having trouble with this, it clearly says there's something wrong with academia as it is. And, I don't know, I just kind of got to thinking about it, and, I just kind of want to continue working on this YouTube channel thing. YouTube and Twitch and all the other outreach stuff. I just think it's a good idea. Because, it'll give me an edge in a way. Not necessarily in research, but it'll help me become a better programmer. It'll help me become better at understanding little things here and there. And though it won't help me with my funding crisis, it could potentially give me a small community to kind of double check my work with. And that's good. That's exactly what I need. The other thing I want to point out is over this past week, it's not only US, I think people here in are pretty pissed about funding going on a high visibility fluff project. Yeah, I don't know. It's just a pain. The whole thing is just a pain right now in terms of science funding. One more thing I want to point out, or two other things I want to point out. Last week there was this guy at my work who basically asked me a question about, oh, how do you do the simulation? And I could actually answer him because it was a simulation that we had just done on the channel about the Barnes-Hunt algorithm and stuff like that, or the quantum Monte Carlo. And it was kind of interesting, the fact that I could actually help him because of stuff that I've been doing on the side. And I kind of like that. I like the idea that, you know, I'm starting to get a feel for all these different algorithms and stuff like that. And that's another reason why I just want to continue streaming. Finally, I hit 1,000 something subscribers on YouTube. I think I'm at 1,004 or something like that right now. But yeah, so I'm officially over 1,000 subscribers on YouTube, which means I kind of want to start thinking about how I want to do things a little bit. I think what I'm going to do is every power of 2 from now on, so 1024, 2048, so on and so forth, I'm going to create an additional kind of vlog-y video where I just kind of update everyone on what's going on in my life, because quite frankly, I like hearing people talk about that kind of stuff on YouTube. I don't know why, I just enjoy listening to people talk about their lives and stuff like that. It's just kind of nice. In addition, I think I'm going to try, I really am going to try to give videos out more frequently from now on. I have been trying, but I've just been failing miserably. For some reason, I'm stuck at getting videos out every 6 weeks. And I don't want to litter people's subscription boxes with stuff that they don't want to watch, you know? So, even though every video takes a while to get out, I think every video I've been putting out lately is very good. So, I think that's okay. So we'll see how far we get there. I would like, again, to publish maybe twice a month, but if I only publish every month, or heck, every other month almost, that's still okay. You know, I think that's okay. Anyway, now let's go ahead and get started. We've got a lot to do today. We'll see how far we get. And of course, guys, if you have any questions, comments, concerns, let me know. First, I'm going to start by seeding into the appropriate directory. Projects, Simuleos, and color quantization. Let's go over here, CD projects, Simuleos, and color quantization. Oh, one thing I want to show you guys before going any further is I actually... Let me go ahead and pop over here, grab this, put it on every desktop, and then I want to pause it real quick. And I realize that's kind of weird, but I did something, and I want to hear you guys' opinion on it. So if I do MPV, and then I run, let me see here, if I run, where am I going? Storage, videos, then I want to go to Simuleos, oh no, not Simuleos, sorry, color quantization. And I think it's out.mp4. Okay, I did something with the color quantization, and I thought it turned out pretty well for the intro to the next video. I just wanted to hear you guys' opinion on it. So here's what we got. Oh wait, you guys can't hear that. But anyway, here's like what I'm gonna do. Right, basically the color's like super poorly quantized, and then I keep snapping my fingers, and it kind of, you know, becomes better. And that was how I was gonna introduce my next video. I'm pretty excited about it. It looks pretty good. I'm pretty happy with that. So like it starts out really crappy and then it gets better from there. Okay, sorry, turning back on the music. Sorry to kind of detract from the point there. I like the idea that you're doing here. This is how you get the tools to make something great later on when doing real research. Yeah, it's just in my case, the tools that I'm getting here are basically, how do I put this? The tools that I'm getting from this particular channel are like little snippets of code here and there. In the end, I would love to be able to like kind of just develop algorithms on the fly for my research, and that's kind of what we're doing here. Anyway, I've been talking way too much about random things that don't matter in the end. Let me see, not many academics. By the way, Happy Little Rat, I think it's really cool that you've gotten so far without ending up going to university yourself. That's really cool. Let me go ahead and get a quick sip of water, and then we'll get started. I've just been rambling like crazy today. I apologize for that, guys. Okay, so what are we gonna do? Again, today's a boring day. I get it. I totally get it. Don't worry about it. If you end up hopping in and feeling like, oh, you don't want to watch today, I get it. Tomorrow we'll be back to doing probably OpenGL stuff. That's what we'll spend most of this week on. I've got a conference this week at the Seaside House at Oyst, so that's actually, you can see it from my window, but you guys can't, but I can. It's right over there. Let me think. It's for the next 2 weeks, so from basically 8:30 to 8 every day, so 8:30 in the morning to 8 o'clock at night, I'm going to be busy doing, well, that kind of stuff. So I'll let you guys know if I go to bed late or anything like that. I'll let you guys know, how do I put this? I will let you guys know if I go to bed late, if I'm not able to get up in the morning. So I'll be like, hey, look, I'm going to bed at 10. The chances I'm going to get up in the morning are like, well, 10 is fine, but I'm going to bed at midnight. Then I'll say, the chances of me getting up in the morning are like negligible. So I'll let you guys know that the night before and stuff like that. So I'll update my channel to say that kind of stuff. Now, what else do I want to say? Let's see, just little snippets, but you'll learn to make much better implementation algorithms. It'll be all the way off by easily. It'll all way off by easily. Yeah, that's true. Okay, so what are we gonna do then? Let me go ahead, LS here, and let me show you guys something that I thought was really interesting. I took an image of basically my face. I feel bad. I feel like really self-centered in a way because all the faces I took all the pictures were of my own face. Whoa, what'd you say happy little rat for? Let me see. So what do we want here? So let me go ahead and open up Mirage Flower Power 2.png. And let's see. Here's the image that we had been working with. Here's an image that my roommate gave me. Let me see. Those are some video pictures of my eyeball. Where are we? Oh, there it is. Okay, we can actually create like really, really crappy filters with this, which I thought was actually kind of funny. So there's our crappy filter. There's the original image. There's the crappy filter. That's the picture of me that I was working with. Anyway, I thought it was kind of funny. Okay, so let me go ahead and clear here. And let's go ahead, ls, open up color quantization.py. Now here's what I did, guys. I went ahead and took the determinate visualization that we had before, which works pretty well. It places spheres where you want them with a particular color. And I said, okay, well, now we're just going to modify it. And we're going to do this for basically a whole bunch of pixels in an image. And the way I see it, guys, this shouldn't take very long. I should just be able to put all the particles down, then I should be able to plot the octree data, and then we should be good to go. That's all I really want to plot. So let's go ahead and go through and let's see what we got here. We have create connectomy 2. All that does is create a line from one point to another point. I don't exactly remember why I needed that for the visualization of, let me see, for that kind of stuff, but that's okay. Now let me see, I have the input set as out.dat. We might have to go back into the other code to kind of work with this. Again, today has not been prepared at all, and I do apologize for that. Yeah, I know, it's kind of a messy, the whole thing's messy. Anyway, the main stuff goes on down here. We do visualize determinate. Yeah, it's super messy. I should probably clean it up at some point because I use it for just about everything, but we'll worry about that when we get to it. Okay, so we have Monte Carlo, which we're not going to need. What do we have here? We have hide interior. Let's go up to the Monte Carlo part of this. So where is Monte Carlo? Monte Carlo. There it is here. So here's what we're doing with Monte Carlo. Basically, we have the ability to hide all of our particles. And let me see, where are we placing the duplicates? X, Y, Z, count, MCID. That seems fine to me. If inbox in exterior, what did we do? We created an MCID, MCB. Okay, that seems fine. And how do we read in this place duplicates thing? 1 second. Place duplicates. Create MC spheres. That's what I want. Create MC spheres. 0.05. Where are we there? Create MC spheres. Create MC. This is gonna be super messy, by the way, guys. I apologize for that. Okay, so we have 3 different materials, red, yellow, and blue, which is fine for here. Here we want create new sphere Monte Carlo. Where is that guy? 1 second, I'm just kind of going through and refreshing my mind on this. Create new sphere. And we should have, 1 second. Oh, it's just new sphere. Monte Carlo. There we have that, Here it is. Okay, so we have X, Y, Z, RGB, and ID. Good. That's what I want. I just remembered I'll have some Japanese vocab reviews to do. Be right back. No problem. In chat. Good, good. So yeah, please feel free to, again, today's going to be one of those in and out days. I get it. I totally get it. If you guys are kind of bored of my stream today, I get that too. Don't worry about it. I'm not offended. But of course, feel free to pop in and say whatever you want in chat. Hey, that's your fan. What's up? Okay, here is the function I was looking for. New Sphere MC. Here's the idea. I want to do a couple of different visualizations. As you guys know, with color quantization, the idea is rather simple, right? That's fine. That's your fan. Okay, so here's the idea. We have, it's okay. Hey, Duck of Doom, what's up? So here's the idea. With color quantization, let me just go ahead and pop it up in Zernal so we don't have any questions here. Zernal. Okay, here's what we got. Where's my pen and where is my board? There they are. We have a whole bunch of particles spread out in space. Each of these particles are the colors of individual pixels on our image. What we do is we split this up into a box, and we continually subdivide this box further and further and further until all particles have exactly one box that they live in. Something like this, that. 1 second, I'm still subdividing our boxes. Something like this. Now, this is in 3D space, so instead of quadrants, we have octants, right? Because 1, 2, 3 creates 8 octants. Now, what we're going to do is each of these particles, again, could be in XYZ space, or they could be in red. 1 second. Green. And blue space. And I just realized you probably can't see that corner over there. So let me see if I can zoom down a little bit. Maybe that helps just a hair. Okay. So what does this mean? Well, it basically means that we have now a color spectrum. I want to do a couple different visualizations. First, I have to get the visualization of the octree. That's where the hard part's going to be, but it shouldn't take that long. Then I basically want to plot all the particles in blue. Then I want to change all the particles color. That's literally all I want to do. Just have the ability to change all the colors at will. So I need to create some dummy data here that basically has all of the particles' individual positions. So we'll have X, Y, Z. And of course, X, Y, Z will become red, green, and blue in the future. So we should be able to plot two different things there. So first we're going to plot everything in blue, then we're going to plot everything in color, then we're going to plot octree data for both of those as some sort of, how do I put this? Some sort of video of everything that we need to do. So let's go ahead. Let's go ahead and strip down the code and get started. This code again is coming from the determinate visualization, which unfortunately, though it turned into a video, I did take down on my channel because there were some questions about certain things on it, and I got kind of putty about it. So I feel like that was my bad. I took it down prematurely, but that's okay. Let me go up to the top. And we have this thing called parse data, right? So parse data basically takes in the file that we want, and it outputs everything that we need. Now, what I'm going to do, I'm going to modify this up here. So for this particular simulation, we're probably not going to need this connect to me stuff. However, we have this version of the code up somewhere else, so we can take a look at that later. I'm just going to go ahead and comment this out for now. Man, sorry about that. Man, I am super just blah right now. Okay, so we have a whole bunch of different ways in which we can read the file. That's perfectly okay. Offset equals 0, lines of data equals 0, importing data from file. Now, here's what I want to do. When input R as data, basically what we're doing is we are reading every single line in of our particle data. Now, the idea here is that we have a whole bunch of different particles. So we have, I don't know, thousands or however many different particles. What I would like to do is I would like to plot, let's say 10,000 different particles. And the reason I want to plot that many particles, or rather, let's plot every pixel in an image. Let's do it that way. The reason I want to do it is simply I want to see how bad Blender is at rendering something of that size. Because if it's okay, if it can do it rather quickly, we might skip out on the OpenGL stuff entirely and just do all the visualization with Blender again, which would be okay if we want to do it that way. No big deal there. We'll see how far we get. Okay. So we have this place spheres guy right here with min velocity, max velocity. Well, in our particular simulation, we're not going to be placing spheres in this way. We'll leave the function in there, but we need to use a different place spheres file or a function. So let's go down to new sphere. Let me see. Here we are there. And let me see, where do we do the place spheres? Let me go down to place spheres. There we are there. And we should have, let me see, place spheres, place spheres, place spheres. Okay, so let me go down to the Monte Carlo. Down here at the bottom. And I realize that this is going to be kind of hard to follow. Again, I mentioned that at the start, so I don't feel so bad about it. Create MC spheres, that creates let me see, here we are, Monte Carlo. If inbox in exterior, what do we have here? Place duplicates, that's what I want. Substrate, Colo Elf Lord. Sure, I don't know what that means, but thanks for coming in. Okay, so what are we going to do here? Basically what we have here is we create the individual ID for all of our spheres. And then after that, we go through and we, let me see, what do I do here? We then place the duplicates. And that's the important part, placing the duplicates. So let's go through and let's do it. I'm going to go up to the parse data, again at the very top here. And I'm just going to remove all of these lines that we don't need anymore. All this connect to me data, we won't need it for this particular simulation, especially because all of our boxes are square. Okay, offset here, input there, let's go ahead and remove that. Out.dat, we'll keep this one, but I think we call it pout.dat, just so that we have something to say there. Oh, I see. It's Vim command to set the color scheme. I see, my bad, substrate. Okay, so what are we going to do here? For line and data, line is equal to that. Temp float s in line temp dot split. Temp 7 equals int. We don't need this one or that one. Good. So now we're going to say array append. Num part here. Let's go ahead and remove these guys here and there. Number of frames. Sure. Lines and data set. That should work okay. Print found. Number of frames and num particles. Should be okay. Yeah, I like black and white. Sorry about that, substrate. I realize it's kind of hard for some people to see, but I'm kind of used to it. And a lot of people watch the channel regularly are used to it. One thing I'd like to point out is I've been thinking about it a lot lately. I am kind of thinking about migrating to Vim from VI. I get that. It's just there's a couple of things here and there that just bug me about Vim. Just because I'm not used to them. Like the ability to move around in insert mode drives me nuts. Because then I don't know if I'm in insert mode anymore, and I sometimes try to execute commands. Just little things, but that's okay. So for lines in data set, what do we want here? Move spheres. Yes, we want all of this. All of this looks good. So what do I want to do next? What we're going to do is we're going to split all of them up. Good. Temp equals float s for, yep, good. Good, good, good. Okay, one last thing I want to do here. I want to, let me see, undo the last thing I did. Nope, that's okay. You can disable arrow keys in insert mode. Yeah, maybe. There's probably a whole bunch of things that you could do. I need to kind of get into Vim and fix it up. The thing is, the way I see it is, no matter what, almost every computer has the ability to open up VI in the way that I want it to open up. Yes. So, let me think. What do I want to do? Oh, yeah. So, for Vim, I'd have to create like a specific, I don't know, configuration file and stuff like that. It's just, I don't know. I've got a whole bunch of reasons why I don't use Vim, and all of them are very weak reasons. I know that. I totally do. But we'll get there. Okay, so what I'm going to say, color quantization here. Seems good. Okay, so this means that we have all of the individual, how do I put this? We have all of the individual positions. Now, let me think. I should have something that allows me to read in colors, and also place spheres. So let me see, temp sphere is this, new sphere there. Seems good to me. Okay, new sphere Monte Carlo. Okay, so that just reads in the XYZ diameter and stuff like that. You bound wait, what? How do you insert commands then with Vim? If you don't have the colon. Okay, that's actually kind of confusing to me, but that's okay. So, new sphere, Monte Carlo. Always ended up doing... Oh, I see. So you flip them. Okay, fair enough. I've cut down on customizing more and more along the years of working. One thing I want to point out, my roommate actually has the caps lock key as escape, because obviously in Vim you use escape literally all the time. And so he has it set there. So let me see, new sphere Monte Carlo, what is the difference between these two functions? Be by contact, active object, color RGB. I actually don't see the difference here. Matte append temp sphere. ob.name, color. Huh. What is the difference between these two functions? XYZ, RGB, ID, segments 8. Oh, I now see the difference. Difference is in the temp sphere that we're creating. Yep. Okay, but I think what we can do is we can actually just create the new sphere. Vim works great on small laptop keyboards. Yeah, that's true too. Okay, so what am I going to do here? What I want to do is basically create a new sphere. No, this should be okay. So we have parse data for lines and data. Yeah, this should be okay. So here's what I want to do. Not much, I'm so much less productive without Vim key binding. It's not even funny. Yeah, it ends up being that people who use Vim a lot, or VI even, they get sucked into the cult of Vim, and it ends up being so hard for people to, I don't know, at least for me and the people that I've seen, it's so hard not to use Vim key bindings. Like, for example, if I'm just over here and I'm typing something, like I'll say, I don't know, I'll run one of my codes, so I'll say, I don't know, -H, whatever. And then I go around, I'm like, oh, I need to fix something. I'll press escape a couple times, and then like all of a sudden I won't be where I need to be. I'll press A at random. I don't know. I don't know. Why do you use Python here and not C++? Please give a detailed answer, not judging. Steve, let me just go ahead and write and quit here, and let me do an ls. We actually are currently using C++ for the color quantization video, or the color quantization stuff. However, for the visualization, I'm going to be using Python because it is a Blender script. And the Blender script is basically, it has to be in Python. That's the reason we're using Python. In the end, that's really the only reason people use Python, because it has good library support, in my opinion. Okay, so let's pop down here. Well, it's not the only reason. I mean, I know a lot of people use Python for a whole bunch of different reasons, but here it's simply because the software that we're using has a Blender script. Maybe it's because I'm not using Nix either. I haven't been using Vim in years, and I'm pretty sure I'm much more productive than I would be when using it. Again, people just get used to it. And again, I do agree with Gustron for Vim like editing. My old internet browser that I used, which was LuaKit, here is LuaKit, had some sort of Vim bindings all the time, so you could do help, and it would bring you help and stuff like that. And it's super useful. It's just, you get used to it. By the way, I would totally suggest LuaKit to you guys. It is fantastic. I love LuaKit. It's a great browser. Okay, so what I'm going to do, let me just do it this way. So where are we? We are move sphere. Let me see what we had before. So let me VI. Back into visualization, into determinate. And then let me open up determinate.py, which is a file we had before. Now, we should have a place duplicates. Duplicates. Here. Okay. XYZ ID, OB ID. Yes, that's what we have. However, unfortunately, in this particular case, every single sphere is going to have a different color. So let me see. How do we change the color of the duplicates that we're placing? That's not so bad. However, I think we'll just do it this way. So we're going to say new sphere, Monte Carlo, just because we'll use this for now. We'll say diameter is 0.1, then we'll give it an X, Y, and Z location of temp. Let me see, what do we have here? Let me go to the top here. 1 second. Place spheres array. Where do we have everything defined? We are returning number of frames, seems okay, but we also need to return a couple of different guys. Once you use it's very fast. The fact that you can easily change words, yeah. Probably, yes. I'm not sure exactly. So let's go down here. What do I want here? going down to render movie. Let me go up to the top here. Oops, sorry about that. I'm hopeful about Vivaldi. I don't know what Vivaldi is. Feel free to talk about it. Okay, what do we have here? Number of frames, int. Let me see. Play spheres. Good, good, good. I think float S for S in line, temp 7. Okay, so I think we're just going to be using temp of, let's do 0. Temp of 1. Temp of 2. Temp of 0. Actually, I'm just going to do this because I'm kind of cheap. Copy these guys. There. And end parentheses there. I think this will work. Let's go here. Let's run quit. Now let's run Blender. And actually, let me go down to the bottom because I don't think we need all of this anymore. So we need parse data. Visualize determinant we don't need. Let's see, data scene, scene update, render movie. We don't need render movie either, just scene update, and that should be okay. So let's go here and let's go ahead and do blender-p. What do I want? I want color quantization.py. Okay, let's see how bad it breaks. Requires 4 arguments. Oh, oops, my bad. It's capital P. Now let's see what happens. Give it some time, and let's see what we got. No file or directory pout.dat. That would be a bit of a problem, wouldn't it? My point about VI is that I'm much rather using an IDE with an integrated debugger and a variety of other tools than a very extended text editor. It's up to people, right? Let me see. I'm hopeful of Vivaldi. I use Chromium nowadays. It's way too convenient. Oh, interesting. I didn't know you could use publicity for that. It's why I use Visual Studio with Visual Vim on Windows. Fair enough. Honestly, you should use an IDE with Vim Emacs key bindings. Unless you're using some esoteric language, there's really no reason not to. Senior publicity, I would like to point out that for my work that I do, I'm SSH'd onto another machine. And in that case, like literally, I'm always SSH'd onto another machine. I cannot do any work on my own computer. And for that reason, I would say that it doesn't make sense for me to pull up an IDE because it's simply going to be slow. I really should be using Vim in that case, or something like that. And I see no reason why I would ever pull up an IDE if I'm always SSH into another machine, simply because that's only going to create some lag, you know, because most, how do I put that? Most IDEs are kind of slow. Let me see, I missed a couple things. Hey, Invictus say, let me see, what are we doing? This is actually a fair point. I'm used to developing on local machines, testing on a remote machine. Yeah, so that's the thing. My own machine doesn't have a an NVIDIA card. And because I'm doing all CUDA support, it has to be on another machine. Just throwing that out. If I was doing basic C++ or really anything with OpenMP or anything like that, I could do it on my own machine. And it's just different. It's different. Is there any reason for not using syntax highlighting? Or is it just me being a dyslexic here and not being able to code without it? I just don't like syntax highlighting. It's something that it feels weird to me when it's on. So let's go ahead and create the data we need. And let me go into, what should we do here? It takes about 40 seconds to run our color quantization code. So let me go into color quantization.cpp. And what do we have here? We have a giant for loop for a whole bunch of data that no longer exists. So let's get rid of that. And let's go ahead and call the quantize function. So let's go up here. Oops. I should probably comment it out up here. I wonder, does this work? We'll see. Let's go down here. Let me see, what did I miss? See, the Steve Chromium more readily available on Linux. True. I'm a dirty Windows user. Okay, so what am I going to do here? I'm going to say quantize. And what do I want? I want to say quantize the file that I want. So let me go ahead and do ls here. Let's see, what do we have? Let's do flower power. Let's do flower power. Why not? As the image. So we will say flower power. It's a big image. You'll see it in a second. Then what do I want? I want out file to be, what is out file? We'll call it out.bmp. That should be okay. And then color resolution we'll say is 8, just to kind of make it easy on ourselves. Okay, so now let me go down to quantize. Best $70 in years. Oh, let me see. I'm gonna do ST3 is a fantastic piece of software, though. I missed ST3. What is ST3? Oh, I see. It is I see. Okay, so what am I going to do here? Particle output. Let's go ahead and do that. Particle output there. Seems good to me. Root P output. Oh, actually, I've got a feeling that's not going to work. But let's go ahead and open up P output up here. Delete root. Should be okay. Yes. I modified some things here and there, but it's all basically the same. I think this is going to break, though. Let me go ahead and write this. Go here, and let's make it. And let me see where it breaks. I've got a feeling it is, because I changed the way particle output works. But maybe it'll still do it. Is it going to still do it? It's compiling, and it's taking some time. Did I just freeze my computer? No, okay, it works. Well, kind of. Let me see, what happens? CImage instance, CImage flower power. Oh, that's because it is not flower power. It is flowerpower.png. My bad, guys. .png. And let's make that. Let me see. $70 works background developer. So use PyCharm, auto upload, run integrated desktop tests, and pass. Yeah. So I think you guys are right. If I was anything but a how do I put this? If I was anything but a numerical physicist, I'm not even going to call myself a computational physicist. If I was anything but a physicist, I'd be coding in a completely different way, and I get that. You know, I'm not trying to push my way of programming on anyone. It should take, I want to say, about 12 seconds to get everything done. Oh, but we're doing particle output, so maybe it takes a little bit more time. We'll see what happens. I have to use a remote machine because we host all of our servers on proprietary servers with internal hardware security. Yeah, fair enough. And again, guys, if you have any questions, comments, concerns, today's kind of a chill day. So let's go ahead and look at our output data. So let me do mraj, sorry about that, out.bmp. And you'll see, oh, look, we have our flower that originally looked like, oh, that's my face. That's not the flower I meant. We have a flower that originally looked like this. So let's do mirage flowerpower.png. Originally looks like this, and then it becomes quantized and looks like this. It actually works, which is really cool. I'm pretty glad about that. So now let me go into pout.dat. Let me make sure it is exactly what I want. This is all 0.5. That's not what I want. So is there a necessity to not test local? Interesting. Yeah, it depends. I think it's not common. I think most people do. How do I put this? I think most people do test on their own machine and do the, like, how do I put this? They develop on their own machine and test non-locally. Let me see. Have I heard of Golang? I'm not too familiar with it. Am I familiar with it? Let me see. Let me see. If you are, is there a reason to switch from it to C++ or anyone experienced with it? So all I know is that the languages that people use in numerical physics, computational physics, are C++ and Fortran. That's basically it. But yeah, if you're good with Go and everyone else is good with you using Go, then it seems fine. You know, I don't see any reason not to use it. So let me go down here and let me check something. When we do particle output, where are we? Particle output is here. We're reading in root. What am I actually outputting there? So let me go down to particle output. What are we outputting? Oh, well, that would be the issue, wouldn't it? Particle output is only outputting one individual. That's okay, Andigi. Thanks for coming in. There's a lot of things I don't like about C++, but I stick with it because compilers are very well developed. Yeah, I totally agree. I mean, so this is the thing, like Julia, for example, is really, really trying to be the next big thing, you know, and I like that. I like the fact that it's going to be or it wants to be the next big language, and it's relatively fast. However, it's not there yet. It is not there yet, and there's a lot of other languages that want to take the crown of the next C++, you know, or in my case, the next Fortran. But that's okay. Let's see, current pvec.size. I think I just need to change all these zeros to i's, and we should be set. So ri, and let's go ahead and do it here and there. There and there. Okay, so now we have current pvec, px. Yeah, so let's see what happens. Let's go and write this, go here, and let's make it one more time. Give it some time. It took 40 seconds last time. It should take about the same amount of time this time. I run unit tests locally because our unit tests mock out external calls, so there's no reason to use a remote server. But if I'm writing an integration test, then I use a remote server. Fair enough. Compilers will develop, but sadly has passed when the language matched hardware. What do you mean exactly, Happy Little Rat? I don't know if I fully... but here I am working with C++, and it's the only real option for what I do. I think that's true for a lot of people. Let me see. Still kind of reading comments here. There was a CPPCon talk yesterday. Oh, dude, is CPPCon? I every once in a while, like, I realize I miss a whole bunch of good talks. Let me see. If I were to switch, to be honest, I might as well do C instead of C++, because after my web dev studies, I want to do embedded systems. Let me go ahead and open up pout.dat. There's still 0.5. What? Why? Let's go ahead and quit here. It should be... let me see. Particle output node current. You know, I'm realizing this is kind of silly. The way that I'm currently outputting particle data right here. This is silly. Let me just... We have the PVEC that we're working with, right? Let me just output it directly. Why am I doing all of this nonsense here? So, node current. Yeah, let me just output it directly. Forget about outputting to node. Let me just do std. Oh, actually, wait a minute. I'm doing a little bit differently here. Let me just quit here. Let me think. So every single individual particle has its own PVEC. Let me output that real quick. I've got a feeling I'm doing something silly here. Let me see. So we have quantized color PVEC image. That seems fine. Where are we reading in PVEC? Oh, I just realized something, guys. We're good. We're good here. Divide octree needs root. Let me do a couple of different things. So let me also output octree stuff. So we have octree 0. And let me just do a couple things here and there. So what I want to do is output the octree stuff. Here's octree stuff. And I want to make sure this stuff is still working. So I'm going to read in a very small image instead of the image that I was reading in before. And then I'm just going to plot it with NuPlot just to make sure everything's working. So the flower power 4. And just to make sure that we are actually still outputting the octree data. So let me go ahead and make that. Should take almost literally no time to work with. Duck of Doom, I will see you around. Thanks for coming in. And of course, hopefully see you around next time. Let me see. If I miss anyone in chat, let me know. I apologize for that. I'm, of course, not intending to. So let me go ahead and do... what do I want? NuPlot. CubePlot. Minus. Okay, good. So we still have all the cubes working just fine. Here's all the data from our image. Good. Which means particle output should be working in this case. Because all those particles are correct. So let me go into Control D, VIP out.dat. Oh, huh. Why did it work this time? Let me try this again with just flower power. And let's go ahead and right quit here, and let's try it one more time. Oh, oops, not what I wanted. I want to do make. Give it a second, it should take about a minute to do. And let me see, what am I missing in chat? I mean, you can always just write C code. Yeah, no such thing as a zero-cast concurrency, but yeah, for finance terminals. Is that a startup? Wait, finance? I totally missed that. Let me see. Exactly, it's not actually part of C++ standard. Finance. I missed that, but that sounds really cool. At least I think it's cool. I don't know. I find weird things cool, right? I should also probably commit this version of colorquantization.cpp to GitHub. I tried a couple of different optimizations past here, but they all just slowed down the code. Like, I spent this entire weekend trying to speed this up, and I just couldn't do it. So I said in the end, screw it. It's slow, but it works. And I'm okay with that. You know, that I hate it because, as Happy Little Rat said, it could be done in real time, but I just couldn't get it that fast. No matter what I did, I just couldn't. We might actually, at some point, bring up an optimizer like Valgrind. I think is one that everyone uses, and I think I would love to work with that for just a minute, just to see how we can optimize our code better. Was just faintly interested for a moment. I've been active as a business angel. Angel? Let me see. Happy Little Rat, I've been pretty excited about coroutines. Coroutines. Are those like, let me see. I know we have coarrays in Fortran. Let me see. I don't know very much about them. So, I mean, feel free to talk about them in chat if you want. And every time I say feel free to talk about it in chat, it means I'm super interested, but I don't know anything about it, and I'd love to hear people talk about it. Okay, let me see. Again, this is taking a little bit longer than I thought. Oh, shoot, I know why. Oh, gosh. I know exactly why this is taking so long. Let me go ahead and quit this. Let me go ahead and open up pout.dat. These are all at 0.5 again. Not exactly sure why, but they're definitely all at 0.5. Whatever, doesn't matter. Let's go ahead and change this flower power 4 again because we know that one worked. Go over here and let's quit. Let's go ahead and make. Give it a second. It should take almost literally no time. We have our data. Then I want to run blender-p and see what's happening. For image processing, what am I missing? What coroutines are for functions, loosely. Okay, fair enough. So now let me go ahead and run the last Blender command, and let's see what happens. All right, nothing happened. It broke. Good. Let's go ahead and see where it broke. Quantization.py line 534. Parse data. Let's go ahead and fix this. Missing one required argument. ID. Oh, okay, fair enough. So what I want to do here, let me go and vi color quantization dot py, and what do I want? Let me go down to create sphere MC, which is what I'm currently using here. Create sphere. Okay, or not. New sphere is what it is. Sorry about that. Here we are, new sphere MC. It looks like I missed something. Yes, ID at the very end. So let's go here, and let's just give it an ID of, let me see, new sphere with open. 1 second. Konohamaru. I was watching anime. Why am I here? Oh, obviously you were watching anime. Konohamaru is from Naruto. In case, it's an anime, in case anyone doesn't know. Koreas are cool. Yeah, actually, I don't know. I find a whole bunch of this, like, parallelization stuff quite neat. Let's see, what do I want here? Lock-free containers. Man, I wish I understood a lot of this computer science stuff. I just don't. Lower level, higher level performance penalty. So here's what I need to do, guys. And I just realized this, well, now. What do we have here? We have lines in data set. So what I want to do is this. For, gosh darn it, lines in data set. Let's say I in range. Then let's do lines in data set. Should work, I would think. Okay, so let me see. We have temp, but I think temp is actually 2 arrays in one. It should be a 2-dimensional array, I think. Here we have array. Oh no, it's array that I'm looking for. So let me do array for all these temps. So I guess I'm just have to do 4x here, 4x. Sorry about this, guys. I didn't know my own code. Okay, and here's where things are going to get a little bit weird. So let me do array here, and let's just go ahead and add them all here. So another one there, another one there. 1 second, guys. There, there, and there. And then let me go ahead and add in an I here at the end for an ID. You are a physicist. Yes, technically I have a physics degree and I am doing a physics PhD. Whether that counts me as a physicist or not, that's up for debate. I do have a currently published paper in a physics journal though, so there is that. Okay, so let me go ahead and add here. All these guys there. And of course here. There. And there. Okay, now let's see where it breaks this time. So we're going to run blender-p. And actually, guys, I'm going to run blender-p-b. Just because this will, for I in range lines and data set. Yeah, I should have figured that one wasn't going to work. So let's do 0, 2 lines and data set. Let's see where it breaks this time. Found 1 in 256 particles in first frame. Blender quit. Okay, so let's try blender-p. And let's see what happens. We have a whole bunch of particles. Woo! And actually, guys, this is okay. The colors are a little bit off. I'm not exactly sure why these guys are black, but, you know, we have all the particles we want. That's good. That is super good. Okay, so now we have to put them in some sort of form that is more easy to see or something like that. So what are we going to do? For X, Y, and Z, I'm going to multiply each of these guys by 10. So let me see. When we go down to put all these lines in the data set, 1 second. New sphere MC. 1 second, I'm thinking here. Yes, X, Y, Z are first. So let's go ahead and put that one down. So X, Y, Z are first. Let's multiply each of these guys by 10, just to kind of have some sort of scale. So we're going to say 10 times. And I might want to do 10.0 times, just so, you know, cover some of my bases. Let's go here. Let me see, did I miss something? I still say that lock-free containers have their place, but I agree it's better that you avoid using them altogether. Let me see, go ahead and multiply these all by 10 times. Good, oh no. Running out of space. 1 second, now let's go ahead and add one more here. And hopefully, yeah, right on size. Now let me try running it one more time. And let's see what we got here. There we go. We have all the particles in our data set with all their colors appropriately set. That is nice. Okay, so now what we need to do is create the appropriate boxes for everything. So we have that. I wrote a TMP wrapper once, but it was an abomination. One of my biggest gripes. I agree. Wouldn't want to not have some JustWorks containers. Okay. Guys, feel free to, of course, talk as much as you want in chat. I'm letting anyone new coming into the channel know that. So now what we need to do is, let me go ahead and go into, let me run new plot actually one more time. Run the last new plot. So here's kind of what we're expecting to see, except in a more pretty version. A whole bunch of boxes like this, okay? So luckily the data that we just printed was correct. It looks good. Now what we need to do is create all the boxes around the data. Now here's the thing I need to point out. How do I put this? We have a whole bunch of boxes, and all of these boxes. Oh, did I just freeze my terminal? No, okay, it's working. So let me go ahead. I have no idea what I'm looking at, but it's pretty. I'll get into that in just a second. Let me just go ahead and finish up my thought here, and then I will describe what we have there. So let me do out.bm. Oh, not BMP. Sorry about that. Let me go into vi octree 0.dat. And right here we have basically the octree of one time step. Okay, and what does this mean? Well, it means that we have a whole bunch of boxes, and these boxes are basically how we quantize our particles. So what do I mean? In an image, we have a whole bunch of pixels. Each of these pixels has an RGB value. What we just printed in Blender, let me go ahead and right quit and run the last Blender, is each of the colors of those pixels. So the idea here is that we have a whole bunch of purple colors in here, a whole bunch of yellow colors, some black colors and stuff like that. And you might be asking yourself, what image are we looking at here? And the image we're looking at, gosh, how do I was just moving around. How do I move around again? There we go. The image that we're looking with clearly has these colors in it, and I'll bring up the image in just a second so you guys can see. It's a very small image for now, just because I wanted to have a small image. Okay, so this is the particle data. So this is all of the individual pixels, the colors of all of the pixels. What I showed here in the octree, 1 second, is us basically giving each of those particles its own box. Okay, let me take a step back then, just so that you guys are in the know. Okay, we have images. What did I just do? Right and quit. Right and quit. We go over here, Control D. I'm going to open up an image. Let's see, what image do I want to open up? Let me do, why not? We'll just do LS here, Mirage. Let me run it on a bit of a different image then. So let me go into VI color quantization.cpp. Let me go down to octree output. 1 second, out. Here we are there. And let's not output the octree data right here. And now let me make it real quick. And then I'll show you guys exactly what we're doing. Again, apologize that this was not clear. I had assumed that you guys had seen another one of these episodes before starting today. I've got a feeling we're going to be finishing today up a little bit slow. I'm rambling a little bit too much. And now let me go up here and let me change one thing. Let me just change this to flowerpower.png. It'll take about a minute, and then I can show you guys exactly what we're doing. Right quit. And let's go over here and let's make. What we're doing here is something known as color quantization. The idea is that we take a whole bunch of colors in the image, we read all the colors in, and then what we do is we basically create a giant box to hold all the particles in. After creating the giant box to hold all the particles in, what we then do is we continually subdivide the box in half and then half again, basically to give every single particle in the image its own box. And after doing this, we have something known as an octree in 3-dimensional space, or what you see on screen right now in 2-dimensional space, the quad tree. Now, in the space that we're working, but why do you do it? Reason is, well, it depends on what you're doing it for, but for most cases, you're going to do it so that you have a limited number of colors in the image. And this allows you to it's not quite data compression, but it does compress the number of colors you have in the image, which makes it easier to store the data. So if you need to do something quick and you need to work with a whole bunch of images, obviously quickly, it's quite nice. Plus, this uses an octree, which is going to be used a lot in the near future. So what does the output actually look like? Let me go ahead and run Mirage out.bmp over here, and let me go ahead and shrink it down over here. And now let me run Mirage, and let's do flowerpower.png here. Okay, so we have 2 images here, and let me go ahead and get these to be of the appropriate size. Move this over here. Good. So this was the original image, and this is the quantized image. Am I too stupid for this? No, you're not. Let me just... The particle naming is a bit confusing. The particle is basically the color of a single pixel in the image. Yes, that's exactly what it is. So what we've just read in is all of the colors in this image right here. We have then put them on a grid on X, Y, and Z, where X corresponds to red, Y corresponds to blue, G corresponds to green. And then the idea is that we take each of these particles, we put them into their own boxes, and then we recursively go through the tree, and we basically say, okay, going back to this example, all the particles in this big box over here, this box over here, let me go ahead and color it in red, this box here, those are all going to be red. Then we say all the particles over here are going to be green, and all the particles over here are going to be blue. And so we basically say that even though this color right here and this color right here, they're different colors, we assume that they're the same color. We quantize all of their colors into one. And it leads us to have basically this, where we have a quantized color scheme. Now, obviously, with the more colors you add in, the better the visualization becomes. So, for example, if we choose, let me go ahead and do quantization.cpp. Instead of 8 colors, we choose, let's say, 256. And we make that. It'll take another 30 seconds or 40 seconds to do, but you'll see that in the end we have basically the same image. And that's really cool, because it means that we have limited the number of colors that we're using. We're only using 256 colors, but it looks just about the same, so we can save a little bit of data here and there. And that's kind of the idea. Again, this is not data compression. This is a compression of colors for later, so that we can have use a little bit less data in the end. I apologize, that might have been super confusing, but that was kind of my quick rendition of what it is that we're doing. Right now we're doing the visualization of that, because in the end I'm going to be doing, I'm creating a YouTube video actually right now on this topic, and I needed to visualize a few things here and there, just so that we had them. So again, next thing that I'm working on is visualizing that octree data, and let me go ahead and do out.bmp over here. Here's the image we have there. Right and quit. And let me do flowerpower.png here. So now you can see the images are pretty close to the same, even though we're using significantly fewer colors. In that tree, does each node have the same amount of daughter nodes? Yes, so if the node has children, it will have 8 children. Or in the image you saw, 4 children. It has to have 8, because it's known as an octree. Yeah. Now, there are other ways to quantize color. This is not the only way. This is just a way that we chose to do here, simply because we've been using the octree for other stuff. And yeah, as Gustron said, it might not contain any actual pixels. Honestly, I find this really cool. It is an incredibly interesting way to quantize color using the octree, which is used all the time for fluid dynamics and like, I don't know, galaxy simulations and stuff like that. It's used a lot in physics, and I just find it really neat that it's used also for computer science applications and stuff. So anyway, here's the thing. With more colors, it looks more or less the same. Even though we're only using 256 colors instead of, I don't know, 4 million colors. I don't know how many colors it's used, but it was way more than 256. And that's really cool. Hopefully the point was kind of across. I got the point kind of across. And you chose the end nodes that contain the largest amount of pixels. Pretty much. Let me see. Clear here. There's a couple of different ways you could do it. The number of colors instead of compress the number of colors makes it a little less confusing. Yeah, you're right. You're right. Reduce the number of colors is totally right. Compressing is not wrong, but people have the idea that compression is specifically data compression. And Steve, you're right. We just chose the largest boxes, basically. So the ones that had the most number of particles in them. So we chose the big box in the center, and then we chose little boxes here and there. That's fine. You took a picture and you made it bad quality picture. Basically, yeah. But again, as I mentioned, the idea here is that we are reducing the number of colors so that we can store it. It has a smaller, basically, footprint in the end. Okay, Konohamaru, I'm sorry about that. Thanks so much for coming in. I will hopefully see you around, but I apologize that this might have been a little bit confusing. Let me do something real quick. So let me do du. Let me see. I think du is the one I want. And let me do out.bmp 728. And now let me do flower power dot png. Okay, 328. 1 second. Let me think. Reducing the size of something hasn't been mainstream for a while. Wait, really? I thought that's like literally what everyone does with their free time. Okay, so 1 second. I wasn't expecting a why question. I figured that. Okay, that's okay. Let me go ahead and do this again then. So let me go ahead and cp out.bmp to another guy. Alexandra, hey, thanks for coming in. Let's do out. I haven't been here for 2 years, I don't think. Out2.bmp. Let me do color quantization again. Let me see. And let's change the number of colors to 8. I don't know. I don't think we'll see anything here because it's a BMP file. But let's see what happens. So let me go ahead and make that one more time. Make. Right here. Go here. Make. We just throw new AWS resources at it. Fair enough. Except maybe video. But YouTube, for example, transcodes at my 16 kilobytes per second stream at 5 to 6 kilobytes per second. Manages to reduce quality at the same time. Not that I need to stream at YouTube, but yeah, fair enough. Again, the idea is that this can be done in real time and a whole bunch of other things, but I'm just very slow at it. Probably because I don't do it for a job and it doesn't need to be particularly fast for me. But again, there are ways to speed this up. Let me see, give it a second to do its thing. Yes, but it's so difficult that 1 month feels like 6 months. Your stream is a time singularity. I will take that as a compliment, I guess. You know, because time always slows when you're having fun. I don't know. So give this a second to run. Let me check something real quick. Du out.bmp 728. Yeah, they're BMP files, so there isn't really much of a difference there. I'm gonna try something a little bit later. I don't know. Maybe there's a way. I would try to figure out which file formats this is smaller in. I'm not sure if any of them actually work that way. But the point is, out and out2 are two different images. We have lowered the quality so that we can basically store more stuff. A nice way to visualize the octree, each box has a shade of color. Time slows down the smoking. Sure. Okay, let me go ahead and right quit. Now, let's go ahead and go into color quantization.py. And let's see what we got here. Okay, so next thing we need to do is basically visualize a whole bunch of boxes. And that basically means we need to work with the cage set function here. So let me go down. My point about reducing size isn't a high on the list concern, is that storage and bandwidth available has gone up so fast, even if data could be compressed and optimized. It's just a niche concern for anything. Maybe that's true. Maybe, yeah, that's probably true. I'd believe that. Definitely believe that. Okay, let me go up to the cage set command and let's see where I use it. Here we are here. It's used there, it's used there. Only these two places. So what I want to do, I actually want to change this guy's location. So we say box length, then I want to give it an X, Y, and Z. So X, Y, and Z, so that each of them has a location. And then we want to do cube add and put this in X, Y, and Z. So X, Y, and Z. Good. Outside of this, let me see. Make frame seems fine to me. So this is exactly what we want, even if technology is getting better. Well, it depends on your target audience. If it is a widely mobile bandwidth, is a legit factor to consider. My music collection takes up 40 gigabytes. To be fair, I did that myself using FLAC. 1 second. I'm not sure where the music comes into play, but that's fair enough. Okay, so now let me go down and let's change the cage set stuff. Here's the idea. What I want to do, that even is worth pounding millions into it to save 1 second. Yeah, that's true too. Okay. So what I want to do is change this function up. Instead of visualize determinant, I want to call this visualize octree. 1 second. Octree. Okay. Luckily, we have everything we need. So all I want to do now is basically go through all of the octree data and plot it appropriately. So all we need is an XYZ location and a box length, which we can read in with the octree stuff, no problem. So let's go ahead and do just that. So let me go into here, right quit. Let's see, what do I want? Color quantization.cbp. We have all the octree data. We just need to output it. So we have this octree output function. I'm gonna change the name of this though. I'm gonna create a new function which is no longer octree output, but it is maybe octree visualization output or something like that. 1 second. Output. Here we are here. Oh, oops, wrong file. .h is what I want. Octree output. Let me see. I find it particularly interesting to see Simuleus use major program languages for scientific simulations. Night change from the usual game application streams. Ah, thanks. I'll be honest, like, I said this a while ago. I find I can't do certain applications. Like, I just get bored of certain applications. Not that some people are great at doing game streams. For example, I think Anyway, point is, lots of people are great at streaming and they make things very interesting. But I personally have trouble doing certain things. I have trouble keeping motivation for certain things. So function to output octree for Blender. Okay, so what I want to do here, what I want to do is I want to say void, and what do I want? I want to do Blender, how about octree Blender, and output, and then I want to do node current, star current, and what do I want here? I also want std OS stream output. And output. 1 second, put. Okay, seems good to me. Let me see, those harder to find flags. Okay, now I'm gonna do the same thing over here. So let me go down to octree output. Here it is there it is there. And let's go ahead and create the function we need. That's obviously a super long function for that one, but that's okay. Let's go down here, grab this, and there. Okay, so we're gonna have to recursively output all of the children and stuff like that. That should be okay. So how do I actually want to do this? I want to visualize each level basically differently. So how am I gonna do it? I'm basically going to output data as box length first, followed by X, Y, and Z position. No, other way around. X, Y, Z position, and then box length. Okay? And then what I'm gonna do is I'm going to, how do I want to do this? I'm going to output X, Y, and Z of every box. Yes, so that's what I want to do then. Yeah, we'll do it that way. Okay, so we're going to say Octree Blender output. Good, this should work. So we're gonna have to do something recursively. So let's go here and let's just go ahead and grab this because we know we're gonna have to use it. And this is gonna be if current children, we're going through all the children, current children of I, seems good to me, except this is now gonna be Octree Blender output. Seems good. Let me see, I thought about converting it to Vorbis. Wait, what is Vorbis? I've never heard about that. And of course, at the very start, let's go ahead and put down this guy too, just so we have all the bases covered. Now, what I want to do next, I want to do the following. So I'm going to output some stuff. So here's what I'm going to say. I'm going to say output. And what do I want? I'm going to say box position. Result is hearing every mistake in all computer audio. Okay. So how about this? I should probably also read in a depth. Yeah, okay, so let me think here. I'm going to want to output. Oh, how about I do it this way? I do this. I output all the children. Let me see, DD here. 4i in each of these guys. And we're going to do output. And I want to do current children I dot p. Wait, how is this? I think it's p dot x because I'm great at this. Then we want to do same thing again. Current children I p dot y. Y. Let me go over here and add a tab. P dot y, and then let's go down to the next line. Add in a new tab. And do current pointing to children of I pointing to p.z. And then we want to output one last thing, which is 1 second. And what do I want here? No, I want tab. Then I want to go down here and output new tab. Current pointing to children of I, and then I think it's called box length. Let me just go over here and check real quick. Node, what do we have here? Box length is exactly what it's called, box length. Okay, and then new line and semicolon. Okay, so this will output all of the children. And then after this, I want to do output 2 new lines. So let's do output. I think this will work. And that should be it. There we go, semicolon there. Right there. Okay. So basically what we're going to do is we're going to output all of that. And let me very quickly grab this and put it up top. I missed something. Steve the Steve. Is there an odd place to ask a question? But is there a compiler option or a macro or any other way to disallow type promotion in C++? Yeah, Gustorn has the best answer to that one. I don't know. So let me see. Divide Octree. What am I looking for again? I am looking for. Oh, I know what I'm looking for. Let me go over to the top. Where are we? Octree outputs there. Let's do Octree Blender output. Then we want to do Blender output. And we want to do root and output. There we go. Let me go up here and let's go ahead and read this in. Pout octree0.dat seems good to me. Now, one thing before doing any of that, let me do output. And what do I want? I want to do root pointing to position.x. Tab. Root pointing to position.y. New tab. And let me see. Root pointing to position.z. Then of course down here, we're going to do root pointing to box length. And then this should be everything we need. And let's go ahead and add in a tab down here. Okay, let's go ahead and run this real quick, see where it breaks. It'll probably break in a number of places, but that's okay. Multi-character content is not allowed. Fair enough. Okay, so let's go ahead and go down there and let's do that. So let's do output. 1 second. New line. New line. Should have known that. Don't know. You look at Toby Maguire. Doug Spiuno. Thanks, I guess. Let me see. I can see compression being necessary evil in game development regarding limited cache expectations. Yes. Okay. So let me check here. 402. Here we are. 402. Let me see. Down here, let me go ahead and add in this, that, and that. And what do I want here? Children has no pointer type node. Children of I should be a node. If current children, output current children. Oh, maybe this does need to be a dot. Let me change that then. All these guys to dots, and let's see what happens. Because I just realized I'm not reading it in as a pointer. Struct node. Oh, I misspelled children. Spelled it as childra. And that should be okay. So let's go ahead and do make here. Hopefully it'll work. It seems to be running. No compiler issues so far. Give it a second to do its thing. Shouldn't take that long. And we'll take a look at octree0.dat. Hopefully it'll be okay. Okay. What do I hear? I'm not involved in that, but I still think this is simply done for cutting size, isn't it? Let me see. Yes, I would imagine so. Give it some time to do its thing. Hopefully it's working. It shouldn't take this long. Run quit. ls via octree0.dat. Oh. I feel like I did something stupid here. Let me go ahead and quit here. Let me go into nedit. Octree0.dat. Let me see how big this is, because I feel like I just made a huge file. 0.25. Yeah, this is probably a little bit too big. Yeah, definitely a little bit too big. Yep. Yeah, it's a lot of data. Let's see. Why are these all the same location? Okay, let's go into... Oop, I should have closed you. There we go. Let me go into color quantization.cpp, and let's see exactly what happened there. We should have, let me see, Octree Blender or something. Let me just look for Blender. Here we are, Octree Blender output. So what are we doing here? Let's put the output new lines in here. Here we are. Because I just realized they were in the wrong spot. DD there, 1, 2, 3, 4, and remove this here. Okay. Let me see. Yeah, Clang has compiler flags for that, I think. Also, unfortunately, guys, it is now officially that time of year where it is too dark, I think, to ever see the ocean again. Sorry about that, guys. It's 6:30 in the morning, and it is quite hazy outside. But we'll see how that goes. Okay. So now let's see, what are we actually outputting here? We are outputting, let's see, all of the children. However, I think that should be okay. Yeah, so we're outputting all the children. Let me open up, let's do top of, what do I want? I want to do octree0.dat. 1 second. Unrecognized field. Wait, what? Oh, top isn't right. I'm sorry. Head. Okay. So it looks like we're outputting all of the appropriate... Yeah, it looks like it's fine. 0.25. Yeah, so let's grab... let's do N100 or something. Okay, so here's the first 100 lines. These actually all look like they're in the appropriate location. It just looks like we have a lot of boxes to deal with. Which is weird to me. So let me see. What do we have here? Are you planning to stream outside or something? No. It's just every once in a while people will come in and they really want to they want to see like the ocean view or something like that. So sometimes I will take the camera and I'll point it outside, but it's too dark now for that. I took a class where I can choose the language they'll teach us, but I'm kind of clueless when it comes to that. So which one should I vote for? It's totally up to you. I would say just because I'm a fan of C++ as your first language, I would say C++. But I mean, there's plenty of good options, right? I mean, it depends on what you want. I think a lot of people like Java. I don't know why. I honestly, it's not for me, but maybe it is for you. So we'll see. Okay, so what do I want then? Well, let me go ahead and run this one more time. So let me go ahead and write and quit. Right here, go over here and let's make it. Actually, let me just go ahead and run du of what do I want? I want octree 0.dat. And it is quite big. It is 202 megabytes. Let me run it one more time. Just make. Let me see what happens. Never do Java? Yeah, okay, sorry, maybe I shouldn't have suggested that. It was just something that I know people have learned quite easily. And even if you screw up, you don't notice it. Take C++ or Python? Or anything? So Python is used quite a bit. I know Python is used a bit. Let me see. C++, again, I think it's just a good standard language. It teaches you everything you need. It's pretty... I think it's a good language to start with, but that's just because I'm kind of biased there. Obviously, it's Fortran. Used all the time in computational physics. That's it. So, fair enough. Let me do octree 0.dat. 203 megabytes, 214 megabytes, 222 megabytes. This thing is slowly increasing in size, and I don't know where it's going to quit. I've got a feeling I'm outputting a little bit too much data here. Yeah, I feel like I am. I feel like this is way too much data. Is this correct? Are we outputting the right... Oh, I don't even know. I don't know at all. C++ is also a good way to teach about the hazards of programming. Maybe. Let me see. This thing is still increasing. Oh, it just stopped. It stopped at 450 megabytes. That's not so bad, I don't think. Although I don't understand what it's still doing. Actually, wait, I might understand what it's still doing. I now fully understand why this is so big. Let me go ahead and go octree, color quantization. 1 second. .cpp. I am outputting, this is not the file I wanted. 4. Now let's make it. I understand now. Sorry about that. I always say logo is fine for a first language, but people throw stones at me or think I'm joking, so I keep quiet now. I actually don't know what logo is, but I do probably need a new logo for my channel. So now let's go into VI octree 0.dat, and this is about what I expected. Okay, this is good. It's not so long. It's everything that I want. And this is all of the data for each of the boxes that we have out. So you'll note that it's always 8 lines and then 2 spaces. That's about right. Good. Okay, so let's go ahead and write and quit here. And let's go into octree color quantization.py. We got 30 minutes. Hopefully we can finish it up. I have been talking a little bit too much. Okay, so what are we going to do for parse data? Well, with line in input R as data, line in data. Let me see. I was writing Fluent Assembly by the time I had first programming course at school. Yeah, that's the thing, right? I find that a lot of times... I was actually watching a CGP Grey video about this last night, talking about the speed at which people learn in class. Usually it's great for like 1 or 2 people in class. Like the way that you teach, the speed at which someone is teaching is great for like, let's say 3 or 4 people in the class, but it's too slow for some and too fast for others, you know? And it always ends up being that, at least for me, the class is too slow, and then I stop paying attention, and then it becomes too fast because I stopped paying attention. That's how it always ends up happening. And so I always just kind of, I don't know, it's a bit of a problem for me in particular, but it's not that big of a deal. Okay, so basically I want to take this parse data function and modify it. The version that didn't have a loop in it, could only draw shapes. Okay, let's see, what do we have here? Parse data. Oh, actually, no. I have the best programming language to start with. Let me go here, let me go to Scratch. 1 second. .mit.edu. Beautiful language here. Actually, while I'm here, let me just very quickly show you guys something. I have a friend. Oh, pretend you don't know his name. Anyway, he does a whole bunch of really cool applications with Scratch. Like, this is incredibly cool. Like, for example, this one. Gosh, I'm clearly just, I'm not even, anyway, point is, it's a pathfinding algorithm where, like, you just pick 2 hexagons and then it goes from there to there, and then you just, like, draw, you know, like, barriers and say, okay, well, you know, you can't go here or there. I don't know, he does a lot of cool implementations here. I find it neat. Spends a lot of time doing that kind of stuff. It is a very easy to use language. It's meant to teach people how to code, and it does a very good job of teaching programming concepts to children, and can be used for a whole bunch of interesting things. It's really slow, and its background is in Flash, so take that as you will, but it's neat. Okay, what am I going to do then? I need to go through this new data file and go from there. So let me go ahead. Anybody ever play with Alice? No. What is Alice? Is it, sorry. I don't know what Alice is. So let's go down here and let me change this to octree0.dat. And let me change parse data, so parse octree. Oops, sorry about that. Octree data. And I realize, guys, yeah, this is kind of a bad way to do it. I get it. I'm sorry. So let's go here and let's do octree0.dat. .dat. Okay. It's kind of like Scratch, except we use 3D assets. Oh, interesting. I might take a look at it a little bit later. So we have these guys. And let me see. So it should be, if line's not equal to new line, good. Number of frames is equal to lines in dataset divided by num part. Should be okay. So let me see. I'm personally looking forward to GAI. Absolutely no starting language, though. I don't know what GAI is. GI. Had to use it in high school, and I absolutely hated it. I desperately try to motivate me to dive more into codinggame.com. Oh, yeah. I've heard of that one. It's really cool. One of the sites I usually give to beginners as well, if after they have got some feet under them. It's quite neat, especially if you're going into game development. I think it totally motivates people to learn. Okay, so let me see. What do we have here? If line's not equal to new line, what are we doing? Temp. Okay. So what are we doing then? We should have some sort of array size. Let me see. Found string and number of particles, first frame. For I in range, 0 to lines in dataset. Should be good. Let's just see what happens if we run this. And we change this guy, new sphere MC, to what am I doing? Not box. Oh, dagnabbit, what did I call it? I called it cage set. So let me go down to cage set. Instead of new sphere Monte Carlo, let's just do cage set. Let me see, this puts them all down there. So 4 lines in data set. Let's see, at frame. Let's go ahead and just do cage set here. So we're going to do cage set. And what do I want to do? I want to read in the box length, which is going to be array. 1 second. Just realized I'm doing this backwards. That's a bit of a pain. So let's go ahead and remove all of this. Let's go here. 1 second. Let's grab it from down here because I know I had it here. Man, I'm just doing awful today. Let me go ahead and paste it up here. Okay, now let's go down here and fix this one. Let me see. Rosetta thing looks good. Job. Some Rosetta code implementations are terrible though, especially the very clever C and C++ ones. Yeah. I know that feeling. Jira's language developed by Job Blow, the guy who developed Braid. Oh, okay, interesting. Freudian lisps. Lips is actually what you said. Gosh darn it. I did a Freudian slip for saying the word lisps. Okay, so what do you say? New sphere. By the way, guys, I always feel bad because I always feel like I have like a little bit of a lisp. Digite, hey, thanks for coming in. Sorry. Doesn't Eigen deal with this? Maybe, I'm not sure. Okay, what do we have here? New sphere Monte Carlo. We don't need that for this particular one. So let's go ahead and remove all of these guys. Now, what do we want to do? Here we have the move spheres command, but that's not necessary in this case. What I want to do instead, gosh darn it, is lines and dataset print at frame here. It sounds good to me. Move lines, good. So let's go ahead and do the following. So we're going to say cage set, and then we basically need to read in the X, Y, and Z locations. It's because someone is doing something about this problem. Not really a simple lib. I just call him Blow, and I think JI misses a few points, but hey. Okay. So for lines and data set, where are our lines and data set? In range, 2 to number of frames plus 1. Sure, sounds good to me. What are we gonna do? We're gonna do cage set. And let me just look at the move spheres function real quick. Move spheres. Here we are. What do we do? For in range, offset number of particles plus offset. Good, 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 good. So let me go up here. And here's what I'm going to do. I'm going to go ahead and set all the cages for what we need. So we're going to say 4 lines in dataset in range 2 to number of frames plus 1. So this means we're going through all of the lines in the dataset that we read in, starting at line number 2, which should be okay. This is Python. Yes, it is. Sorry about that. It's good to have someone doing something about this problem. Man, I am totally like half and half here between actually getting programming done and not. So let's do 4. What do I want to do? Let's say print at frame lines in dataset divided by 100 equals 0. Let's see. So we have these divided into bits of 8, right? Let me see. Temp array.append. Let me just go ahead at frame of number of frames. 1 second. Oh, Blender modeling software? Yes. Yes. Exactly what the issue is. Inventor stuff? Hey, what's up? Okay, what am I going to do? Let me see. So we have lines and data set here. Gosh darn it. All I need to do is put down all of... I just need to read in the file. So let me just go ahead and do this then. Let me just see what exactly it is that we have down here. So let me just print found number of frames and string part number. So let's go down here. We already have all of this being read in. So what do I want? I want parse data. Now let me do number 2 is going to be equal to parse octree. 1 second. Data. And there we have that. Let me go to parse octree data. And let me just go ahead and output, let's see, found number of frames, and let's just output lines and data set. So let's do print. And what am I printing? Let me just do print array. Let me go over here and let's run Blender -b-p. And what do I want to do? I want to do color quantization.py. There we are. And let me see, found number of lines, end of line while scattering string literal. Good. Much syntax, very complex. Yeah, sorry about that. I was supposed to do Japanese reviews. I only did 109. I'm sorry about that, Gusterman. I do find it neat that you don't like syntax highlighting. Sorry about that. I didn't get used to using syntax highlighting, and it seems weird to me when it's on. So what do we do? Simulate color quantization.py, print number lines and string num part, end of line while scanning line literal. Let's go to 74. Okay, so it seems weird to me that this is where things break. So let me just go ahead and put a... Oh, never mind. I know exactly why things broke. This is a copy and paste error. My bad, guys. My bad. D there. And let's go ahead and Blender-P. Okay, good. So we have all the data we need, I think, right here. Lots of data, but that's okay. And let's see. Found 1 in 256 particles on the first frame. Found 1,829 and 1 particle in the first frame. Let me see. I mean, you almost got it correct. That your fan? Oh, yeah, it's actually arigato. So with an A. Okay. So that means we have 0, 0, 0 for the first one, -25, -25, 0.5 for the second one. Good, 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 good. Everything seems okay here. So now all we have to do is print everything out. So what are we going to do there? We should have parse octree data. We have the array that we have to read in. So I guess what we'll do is we'll first start by visualizing the first point. So we're going to say 1 second, let me think. Let's not print the array anymore. And let's go here. And let's say cage set. And what do I want? I want array of 0. I guess. What did I do? XYZ first? Or I think let's do 3. Cage set. How do I read this in? Box length, XYZ, and then the make frame. Good. So let's go here. Box length is first. Then we do 0, 1, and 2 for the next ones. So where are we here? We should be almost there. Here we are. 0, 3. Then we're going to do array of, let's do 0, 0. Array of 0, 1. And array of 0. Oh, 1 second. 2. And finally, we give it a make frame, which I'm going to say is 10, just so that we can see if something works or not. Good, so now we have everything set, so let me go ahead and write this, go over here, and let's run blender-p color quantization.py. And this should pull it up in Blender. Hopefully it works. Good, we have a box at some particular point. However, we no longer have particle data, which is a bit of a pain. So let's see. I did just notice that you have a variable called temp and parse octree. Yes, I do. It's kind of a pain. Sorry about that. It's kind of a pain. All of it's kind of a pain. So let me go down here to the bottom. G, and let me see. Parse data. Let me go ahead and remove this one that we just created. Let's go here and let's do blender-p. Where'd all our particles go? 1 second. Let me do VIP p out. Dot. We clearly have particle data. Right, quit. Where did they go? Scene update, scene frame end. Which I could. 1 second. There, friend, you could have that for Swedish. Okay, 1 second. What I want to do, visualize octree. That's something that we'll use in just a second. Parse octree data should be okay. Remove object from scene. Yep. Where is our parse data stuff? So let me go up to 1 and let's go down to parse data. Input p out.dat. For lines in data set. Open up here, write this. Weird, where is it? Found 1 and 256 particles in the first frame. Lines in dataset move spheres. Oh, you know what? I probably... Yeah, I removed it. My bad. I totally removed the thing that I needed there. Dag nabbit, I can't believe I did that. So let me go down here and let me do 4. What do I want here? I want to say I in range. I just wrote this earlier. 0 to what I'm going to do. Array.size, a length of array would work. We have the array float s array.append temp. Yeah, so let's just do a length of array. I don't remember what I did before, but that should be okay. Here we are there. And now we're going to say, where is it? New sphere MC. And let's grab this guy and put it up top. Let me see, what do we have here? So now we have to give it an appropriate everything. So we're going to say diameter is going to be 0.1. X is going to be array of I of 0. Y and Z are going to be similar. There. And of course here. Now we're going to have red, green, and blue, which is again going to be quite similar. So we'll say red, green, and blue. 1 second. Array 0. Yep, I need a space up here though. And I need this guy here. And then finally for ID, I'm just going to put down I. Now, these guys need to change, so let's do R2. Oh, I'm sorry, R1. R1. And this guy needs to be R2. And there we are. Right, this, go over here. Now let's run blender-p, and we should see we have a box. Is not what I was expecting. Let me see. Oh, 1 second. Now let's try it. Give it a second. Bam, all our particle data is there. Good. So let's change this to, how about 0.01? drop it down in order of magnitude. Let's go down here to the bottom, and let me make sure cage set works. So where are we? Here we are, parse octree data. There we are. Write this, go over here, and let's run blender-p. Here we have this. We have a box. Here we are. So let's zoom in. There's all our particle data. Looks pretty good. Now, what do I want? I want to do... Oh, gosh, there's a way to do this. AV-Sync frame dropping. What am I looking for? Global. This? Let's do rendered. Okay, here's all of our particle data as it would be rendered in this particular location. Now, let's see what happens if we... Oh, that's not doing exactly what I wanted to do, is it? We should have... Ah, there we are. Cube is on the outside. Good. Good. Exactly as I'd hoped. Okay, so now we have to put all the other data on the inside. I realize it looks kind of ugly for now. Digitech, what flavor of Linux do you use? Are you bashing from Windows or something? I can't quite tell. No, I use Arch. I don't know if you were talking to someone else in the chat. I apologize if I missed everything. But yeah, in general, I'm not negative towards Windows. I just don't understand Windows. It seems weird to me. But yeah. Okay, let me go up here to the top. And let's go down to parse octree data. Okay, so now we have to parse the rest of the data, and let's do it. So we have cage set here. Now we're going to say 4. And let's say I in range, and let's say 1 to length of array. Should be good. Now we just have to do cage set. So we're going to do cage set basically of I here. And then basically we're going to do this. We're going to say, how about we do this on frame 1? And then we're going to say, how about, oh, let's do this. We'll say frame equals 1. Oh, go down here. Oh, what am I doing? Go down here, say frame. And then let's go down here and we're going to read in frame every time. Okay. Arch, I could never get it to work correctly on my 970 and I'm on Windows, as I largely like to program in C#. Yeah, that's fine. Again, I'm not bashing Windows. It's just one of those things that I got to be totally and completely honest. When I initially learned Linux, I didn't know Windows very well. And now going back to Windows seems counterintuitive to me. Like it seems weird. I can't understand it. And so it's just one of those things, you know. I wish in some sense that I was a little bit better at life, but I'm not. Okay, so cage set here. And this is what I want to do. I want to say if, let's say I minus 1 mod 8, sorry about that, 8 equals 0. 1 second. I missed a space. Then we say frame plus, sorry, that plus equals 1. Okay, so now let's go ahead and run blender-p. Let's see what happens. It seems not to like that syntax. Oh my gosh, of course, because of C++ syntax. There we go. Let's try that one more time. Okay. Give it a second to do all of the visualization. This should take a little bit of time. So in the meantime, let me just go ahead and move this down over here. And let's see, what did I miss in chat? I didn't specify the novel, I guess, because I got the graphics novel. Do androids dream of electric sheep? Let me see. Friend of mine did after we talked about Neuromancer. Oh, yeah. You guys were talking about that the other day. This is taking a significantly longer time than I thought to plot all of the data. Hopefully this will be okay. Yeah, hopefully this will be okay. Okay, we'll see what happens. Worst comes to worst, you know, it's fine. We'll see what happens. But basically, guys, we got everything we needed to get done for the visualization of this stuff. So what I'm going to do is probably call it in just a second. Whenever Blender pops up, I'm probably going to call it at that point. And what do I want to say? I want to say that I'm quite happy with how the visualization turned out. I mean, we have all the visualization in Blender. We can basically do everything we need. I need to mess around with the camera angle and stuff like that, but it's all there. You know, everything that we need is there. So once it pops up in Blender, I can check to make sure it's all there. Otherwise, I might have to redo the simulation one more time. I'm still in the middle of my Malazan Book of the Fallen reread. Honestly, guys, let me think. I used to do so much reading when I was younger. Reading and writing was like literally all I did. Oh, good. Blender's up. And it's broken. It just quit. Why did it quit? Maybe I had too many particles. So let me go and let me redo something real quick. So let me do color quantization.cpp. And let me see, quantize flower PNG. Let me just go in here and let me change something real quick. So let's see, upstream here, image file there. Vector particle pvec equals image read. Nope, I'm gonna set you to random numbers. Now let's go to make. Hopefully this will work. Let's see what happens. Book of the Fallen. Oh, you're not wanting to. Okay, you seem to work. But you had a segmentation fault. Let me see. P out. Did I get the data I wanted? No, I didn't. Dagnabbit. Let me see. What do I have here? Making octree, dividing octree. Let me see. Number of pixels is pvec.size. This should be okay. What's wrong with it? Line 1, segmentation fault. Corrupted color quantization. Okay, look, I realized I did something stupid here, but what was it that I did that was stupid? I created a random distribution, 0 and 1, for all of our particles. pvec.size. 1 second, image file is in file. Image file is C-string. Yep. I have read Death House Gates probably 4 to 5 times. So you're doing C++ and Python to generate your physics? Kind of, in a way. So what I do is I do all the simulation, usually in C++ or at work CUDA or at work Fortran, depending on what I want. Then we do the visualization in a number of different ways. Usually for 2D data, NuPlot is fine. For 3D data, we use Blender. And the Blender we use Python for that. So yes, you're totally right in this case. But I'm letting you know that we do other things here and there. Okay, vector particle pvec random distribution 0 to 10. That should be okay. My question is, where did it break? Color quantization error 139. We should just have 10 pixels. Imagery, number of pixels, pvec.size. Let me see. Oh, you know what? I bet you it's in the height and width thing, isn't it? So let's see, what do we have here? Divide octree. Particle output. Dang. Okay, that's a little bit unfortunate. So let me see. Where do we do height and width? Height here. Image.height, image.width. Let me see. So let me just do this a little bit differently then, because I'm kind of failing a little bit at generating some data. So I'm going to do something really, really stupid. Let me go ahead and go down to quantize. Just so I can have something to make sure that what I just did was working. And let me see, here are 10 random points. We want to read in a random file. Let me open up GIMP. You guys are gonna hate this, flowerpower4.png. Okay, here's what I'm gonna do. I'm going to open this up, zoom in, then I'm going to do colors, Windows, recently closed, no, toolbox, here. And let's grab, how about 8x8? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 8x8 would be how big? 64? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And let's grab, yeah, that should be okay. Let's grab this one. Okay, so now let's do file, export as flowerpower 5. Okay, export. This is gonna be 64 colors. Surely that's okay, right? 64 should be fine, I would think. This will be fine, this will be fine. Okay, so now I look for 4. Oh, come on. Here we are, and let's change this to a 5. Now let's go over here and let's try blender-p quantization.py. There we go. It seemed to open up, but nothing happened. Probably because I need to do a quick make, and then it should work. Let me see. Initially wasn't fun the Dead House Gates, but grew on me. Yeah, so, man, I feel so bad because nowadays, like, I try to read books, and then every time I'm reading a book, I feel like I should be doing something else with my time. And I know I shouldn't. I mean, reading is fine, but it's just, I don't know. I get the same feeling when reading books as I do playing video games, that I feel like I'm kind of wasting something, and I don't know why. Gives this guy a second to do its thing. Okay, good. So we have a whole bunch of boxes, I think, but one thing I would like to point out is that these boxes seem to be always there. Particle data, lots of boxes. A lot of boxes. Yep. Yeah, we have a lot of boxes. A little bit too many boxes. Okay. So there's currently a bug in what we're doing. Let me see. What do we have? I like have... Yeah, it's fine. It's fine. What are we going to do then? Let's do quantize color, output. What am I doing? I'm in the wrong file. Let me go into color quantization.py. And we go down to bars octree data. Okay. So currently there's a little bit of a bug. And I see the bug. Let's go here. And let's change this to an I. And we should change all of these guys to RI. So let's do RI. There. And there. And let's just, so we can actually see what's happening here, let's change this to 10. And let's change this to plus equals 10. Now let's go to blender-p, quantize color.py. And hopefully this will be okay. Give it some time to pop up. There we go. Okay, so we have all our boxes, but we have smaller boxes. So now we have at least the appropriately sized boxes. So if we... Okay, this is kind of weird. Not exactly sure what's happening there. Let me check something. Rendered. This is what it looks like rendered. It's almost what we want. Not quite, but almost. Okay, we're getting there, guys. Let me see. I meant one half of the intertwined stories, but yeah. Okay, so the issue is that the boxes are not appearing at the appropriate time. So let me see. Why would they not be appearing at the appropriate time? Let me go ahead and print frame. So let's do print frame. And now let's try that again. Open up the terminal. It looks like all the frames are at 20. Interesting. All of the frames were always at 20. Now, of course, if we zoom in and we do the render, it is actually what we want. It's just, there's something wrong about it. I wanted all the boxes to appear at a particular time. Okay. So, let me see, array 1, 2. You know, maybe it's a problem in the cage set function. So let me go down to cage set. Here we are there, here we are there. And let me see, cube 0.001. That is the issue. Okay, I currently see the issue. Okay, we have to change this so that it reads in each of the individual cubes. Sorry about that. And I don't think it's a bad story. Okay. So what do we need to do then? Let me go ahead and run it one more time. And let me read out all the cube names. Give it a second to do its thing. Oop. Way too lengthy. We probably need pencil and paper to figure out the first read through. Okay, so we have all these particles down to 64. And then we have cubes up to 64 there. Yep, looks good to me. Oh, we have a lot of cubes. Shoot, we have a lot of cubes. Okay, so this is something that we need to fix, but it shouldn't take so long. However, it is 7 o'clock in the morning, so here's what I want to do. I'm going to leave this as a note to fix for tomorrow, and we'll fix it up then. I realize, guys, yeah, we could get it done now, but kind of frazzled a little bit. And so this is probably a good place to go ahead and stop for now. So let's go down here and let's say, What am I going to say? I'm going to say, make boxes. Oh, name boxes. So that they will appear at appropriate time for cage set. Okay, that's all we need to do there. Yeah, it's 7 o'clock in the morning my time. I live in Okinawa, Japan. Okay, so let me go ahead and remove one last thing down here. Print frame does not need any more. We know exactly what we need to do for tomorrow, and that is... Yeah, so what I found, last week I tried to change things up and I tried to stream less, but it ended up being that if I didn't get up at 5 o'clock and do the stream from 5 to 7 in the morning, I just couldn't function the rest of the day because I got so used to doing this. But that's okay. That's okay. Malazan is probably not a great topic on this channel, nor for most others here. I'd love to make MMO out of that world. Yeah, definitely. There's a lot of worlds I'd like to make an MMO of. Like, for example, the Wheel of Time series. Absolutely beautiful world. So let me go ahead and do a get status dot. And what do we have here? Color quantization.py, color quantization.cpp. Here's what I'm going to do, guys. I'm going to go ahead and do a get add makefile, color quantization. And I think, yeah, we'll do .py, color quantization.cpp, and color quantization.h. Now, let's see. Should we also... let me see. Every day? It is every weekday. So Monday through Friday. I'm taking weekends off. Definitely taking weekends off because I need that time to prepare and stuff for the next week. Let me see. What time do you tend to sleep at night? I usually go to bed, like I try to get in bed at like 10ish so that I get up around 4:30ish and I get about 6 hours of sleep, something like that. So that's kind of how it is. And yeah, Gustron, I know you're up till 1 or 3 a.m. or something like that because this stream ends at midnight your time. So yeah. Okay, so let's go ahead and add those files and let me do a git commit. Forgive these. This is a very... I've been working on this directory for like a year, so there's a whole bunch of stuff that I need to clean up. I get that. So let me go ahead and do... what am I going to say here? Creating Blender script for visualizing tree data. And let's also say color appropriately quantized for arbitrary images. Okay, so we are almost done with the color quantization. We'll finish up tomorrow and then we'll start working on other things from there on. So let me go ahead and do a git commit or git push, origin master, and then we will call it a day. You guys now have access to everything that we have updated and it all should be good. This is insanely good practice and it ends at 11 p.m. my time. Yeah, so it's good for, I think, people in Europe and the UK. And I think it's also good for people in the US, but it's very bad for people in Japan where I'm from, which is good because I don't want people from work watching me fail miserably at programming. Let me see. Outside of that, guys, let me think. I think that's about all for today. So I will see you guys tomorrow for the next episode of Simuleos. We'll start by finishing this up and then we'll move on to the visualization of our Galaxy Simulator, which will be the very next simulation that will be up on my YouTube channel. Again, as I mentioned before, the next 2 weeks I will be at a conference here at OIST, so I will be able to stream every morning, but the amount of free time I have outside of stream is smaller, so the streams may be a bit of a lower quality, and that's fine. Because I don't think it's particularly low quality stream, it's just I don't have as much time to prepare and I'm letting you guys know that ahead of time. That's it for today, guys. Thanks so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time, and I will see you around next time for the next episode of Simuleos. Should be a lot of fun. Thanks again, guys, and see you next time. Bye, guys.